Neil Armstrong had been getting ready for his mission on the moon for over 3 years. To resist microgravity conditions, he had to learn how to walk sideways by being strapped and suspended at an angle in trying to walk along walls. His limits were tested through an intense diet and sleep regimen, since in space he would only have beef and vegetables, previously dehydrated and stuffed into a package. Back in the day, astronauts had to experience the desert, jungle, open sea, and Arctic survival training. These days it's a lot more structured. But back then, it was more of a let's drop this person in the middle of nowhere with no supplies and see if they make it. Before landing on the moon, he had to gather and study rock samples in the Grand Canyon, explore ancient volcano formations in the Nevada National Security Site, and look into gas and lava vents, lava lakes, and pit craters in various locations in Hawaii. On July 20th, 1969, Armstrong was given a hearty breakfast before blastoff. Steak, eggs, toast, juice, and coffee. He received what doctors call a low-residue meal, which means he wouldn't have to go to the bathroom soon after. It took him 109 hours and 42 minutes to reach the surface of the moon, in an area called the Sea of Tranquility. He had to travel 240,000 miles to get there. The crew could have gone for the Ocean of Storms or the Central Bay, but this place was chosen for landing because it had good visibility, was relatively smooth, and was easily reachable with as little propellant as possible. When he was at about 500 feet above the surface of the moon, Armstrong had to maneuver the spacecraft manually to make sure they wouldn't land in a dangerous crater. He continued to hover for about a minute and a half, moving it sideways until he felt comfortable to land. As soon as his device landed safely, he immediately radioed to Mission Control, located in Houston, Texas. The now famous message,
"The Eagle has landed."
Steadily, he went down the lunar's module's ladder, while a television camera was attached to the craft to record his progress. The camera also transmitted the signal back to Earth, where hundreds of millions of people were anxiously waiting. At precisely 10:56 p.m. EDT on the same day, Armstrong placed his feet onto the lunar soil, saying,
"It's one small step for man, one giant leap for mankind."
The schedule said that the astronaut needed to sleep before the first moonwalk, but he chose to go outside earlier than planned, since he obviously couldn't sleep. If Armstrong had walked on the moon without special equipment to breathe, he would have smelled a weird odor, sort of musty and sulfuric. Still, he had the chance to smell it when he returned to the lunar module. The thing is, the dirt had clung to his feet, so the odor spread all over the cabin. He described it as wet fireplace ashes, or how the air smells after fireworks shows. Who would have thought you needed to pack a scented candle when going to the moon? Apart from the people that have since made it to the moon, no one ever got the chance to know precisely what the crew was smelling. Even during that first mission, when moon soil and rock samples were transported to labs in airtight containers, once they were opened back on Earth, surprisingly, the smell was gone. He also felt the surface of the moon to be fine and powdery, but said he had no difficulty in moving around. One other member of his crew joined him about 20 minutes later. The whole moonwalk took a little over 2 hours. During this time, Armstrong and his teammates set up various devices on the surface of our satellite. One was meant to precisely measure the exact distance from there to Earth, by timing how long it took for a laser beam to travel from Earth to the lunar surface and back. Another meant to measure moonquakes and potential meteor impacts, which leads us to the discovery that the moon was pretty alive after all. We know today that the largest moonquakes are much weaker than the largest earthquakes, though their movements can last for up to an hour, way longer than on Earth. They managed to gather somewhere around 50 pounds of rock and soil samples. They also snapped many photographs of the terrain, where they also planted a US flag. The astronaut even got the chance to catch up with President Richard Nixon, for less than a minute though. The final thing on the list for Armstrong was to go for a walk to what is now known as East Crater, 65 yards east of the lunar module. It was the greatest distance traveled from the spacecraft on that specific mission, approximately the length of half a football field. As soon as his tasks were done, Armstrong went back into the lunar module and safely closed the hatch to get some sleep. While preparing for liftoff, Armstrong and his crew discovered that, because of their chunky spacesuits, they managed to break the ignition switch for the ascent engine. No big deal, they thought. So they used a part of a pen to push in the circuit breaker to start the launch sequence. At 1:54 p.m., the famous Eagle began to ascend. Apart from the scientific equipment installed on the surface of the moon, a plaque was also left there. It read, "Here, men from the planet Earth first set foot upon the moon, July 1969 AD. We came in peace for all mankind." Years later, Armstrong said that NASA limited their time on the moon because they didn't know how the spacesuits would handle the moon's extreme temperatures, as high as 260 degrees Fahrenheit during the day, to as low as 280 degrees Fahrenheit below zero at night. Things got a bit more complicated when Armstrong landed back on Earth, since he had been exposed to unknown space particles. The result? He and his team had to be placed in planetary protection quarantine on their return, as soon as their space capsule safely splashed down in the Pacific Ocean on July 24th. That specific quarantine for the Apollo 11 astronauts is one of the reasons why we have microwaves in our kitchens today. When they first returned from the moon, they initially spent their first few days in a mobile quarantine facility, or MQF. Sure, the MQF featured comfortable chairs, bunks, a toilet, and showers, but it didn't leave a lot of space for fancy cooking. Since there was no room for a standard oven or grill, and to also reduce the potential fires that might have occurred, NASA had to get creative. That's how the original countertop microwave oven was developed, to easily help astronauts get their meals without the hustle of a fully equipped kitchen. These days, you can see that first microwave in a museum in Oakland, California. After returning to Earth, Armstrong claimed he would never reach for the stars again. But he didn't stop exploring, though. Back in 1985, he joined a professional team of other greatest explorers to the North Pole. He was joined by mountaineer Edmund Hillary, aviator Steve Fawcett, and photographer Patrick Morrow, reaching the pole on April 6, 1985. Armstrong claimed he wanted to see what the Earth's icy pole looked like from the ground, since he had only seen it from the surface of the moon. The Apollo 11 mission was nevertheless unforgettable for Armstrong since. In 2015, the Smithsonian Institution uncovered that he had kept hidden a cloth bag full of small parts from the lunar module. It included his waist tether, some utility lights, and their brackets, an emergency wrench, and the optical sight that was mounted above Armstrong's window of the space module. It also contained the data acquisition camera that recorded the iconic footage of Armstrong taking his small step on the moon. Armstrong kept it to himself for many years until his widow, Carol, eventually found it. He even kept it a secret from his official biographer, who at many times asked if he had kept any memorabilia from his famous mission. He didn't sneak those objects back on Earth, though. He just mentioned it to be a bunch of trash he wanted to bring back.
There's something happening inside the moon, something that nobody expected. Not a dramatic shift you'd see on the outside, but deep down, where things seem frozen in time, scientists have uncovered a hidden layer of what you could only call moon goo. Remember those school lessons about the crust, mantle, and core? Much like the Earth, the moon is made up of layers, a crust, mantle, and core. However, the moon's core is much smaller compared to ours. Earth's core is huge. It makes up about a third of our entire planet's mass. The moon's core makes up only about 1 to 2% of its mass, and its diameter is about 1/5 the diameter of the moon itself. It's surrounded by a hard, rocky mantle, but it turns out that between these two layers, that mysterious goo layer, and it's way more important than you might think. The layer is soft and partially molten, ebbing and flowing like the tides in our oceans. It rises and falls, stretching and shifting as if it were alive. Its movement isn't chaotic, but subtle and regular. We always knew that the moon influences our seas and oceans, causing tides with its gravity. But it turns out that we influence it back. The goo ocean reacts to the gravitational dance between Earth and the Sun. Also, the molten layer could be made of ilmenite, a very intriguing material. Ilmenite is rich in titanium, a strong and lightweight metal that we really love over here on Earth. Titanium is used in everything from airplane parts and spacecraft to medical devices, even in everyday items like bikes and laptops, all because it's incredibly strong and very resistant to corrosion and heat. So, if the moon might have a molten layer rich in ilmenite, that would be awesome. Astronomers are already planning for lunar bases, and if we had a material to build structures, spacecraft, or even tools for astronauts right there, that would be a game changer. Otherwise, we'd need to transport materials from Earth, which is extremely costly. This is our first tangible sign that the moon is not just a cold, boring rock. Instead, it's dynamic, living, and breathing, with moving forces beneath the surface. NASA used new special tools to discover this: the Gravity Recovery and Interior Laboratory and the Lunar Reconnaissance Orbiter. These are both space missions designed to study the moon, but they don't just look at the surface like a telescope. Instead, they help measure things we can't see with our eyes, like the moon's gravity and how it changes over time. Grail sent 2 small spacecraft around the moon named Ebb and Flow. Clever. The idea was for these spacecraft to fly close to each other and measure tiny differences in the moon's gravity as they go. It's like they were feeling the moon's invisible pull in different places. If the moon's gravity was stronger in one spot, the spacecraft moved closer together, and if it was weaker, they moved farther apart. This helps scientists understand what's going on inside the moon, even if they can't actually go there. And the spacecraft intentionally crashed into the moon in December 2012 to end the mission. The Lunar Reconnaissance Orbiter is a bit different. It takes super detailed pictures of the moon and collects other important information about its surface. By combining the information from both Grail and LRO, we were able to find this goo layer. But this discovery actually challenges everything we thought we knew about lunar geology. How did this molten layer get there? How long has it existed? And perhaps more fascinating, how it stayed warm for millions of years. That's $1 million questions. The moon's core generates heat just like ours. But it's not as easy as saying, oh, the core's heat probably keeps it warm and molten. Well, first, the moon's core is much smaller and less active than Earth's, meaning it produces significantly less heat. Plus, the moon is much cooler than Earth in general. With temperature dropping to minus 200 degrees Fahrenheit on the surface, how could this inner layer still stay in this flowing state? That's still a mystery. In any case, this goo could actually explain a lot of stuff about the moon. For example, astronomers were exploring moonquakes and how they happen. Now they think that it might be this semi-molten layer shifting and moving beneath the surface. Now, beyond the moon itself, it also tells us more about other celestial bodies. If the moon, something we considered basically a huge static rock, has such a dramatic life, what about other planets, moons, or asteroids? Could they also hide similar hidden movements beneath their surfaces? We can even understand our own planet better, learn more about how tides and similar stuff works. There are so many great discoveries we've been making on the moon. Recently, we found some awesome stuff beneath the surface, massive caves hidden for millions of years. For over 50 years, scientists have suspected that the moon's surface is full of underground tunnels and caves. These are known as lava tubes because they were formed by lava. Duh! Millions of years ago, the moon was pretty unstable. It underwent some volcanic activity, causing eruptions. When a volcano erupts, lava can flow across the surface. As the outer layer of the lava cools and hardens, it forms a solid roof of dark material. It's actually what these famous dark spots on the moon are. These are dark, hardened remains of ancient lava. But the hot, molten lava continues to flow through the center. Once the eruption ends and the lava drains away, what's left behind is an empty hollow tunnel, hence a lava tube. On Earth, we have lava tubes in places like Hawaii or Iceland, where volcanic activity has created similar underground tunnels. The same thing happened on the Moon billions of years ago, although they're much crazier compared to ours. In fact, lunar lava tubes are now thought to be some of the largest and longest in the entire solar system. One such cave was discovered beneath the famous Mare Tranquillitatis, the place where Apollo 11 first landed, and it's at least 340 feet deep. Now, all these lava systems have remained hidden just beneath the surface, untouched for millions of years. Only now, they finally managed to prove their existence. Scientists from the University of Trento in Italy found them using special radar technology and advanced computer methods. These techniques let you see underground by sending radar waves. The waves bounce back and give clues about what's hidden underneath. By analyzing the way these waves reflected back, the researchers could detect the shape and size of the hidden caves. Now, the best thing about this discovery is that we could build all our bases there. These caves protect from radiation, harsh winds, and meteoroids. NASA even found evidence that some of these caves stay at a steady 63 degrees Fahrenheit. That's some crazy coziness for the Moon. And on top of that, there could even be some water there. So humans could take shelter inside these natural tunnels and build entire colonies on the Moon. And I know what you're thinking. Could unexpected lunar monsters hide deep in those caves? Well, sure. There's a huge potential for exploring these caves and finding some awesome stuff. But even if we manage to find a miracle, like small life or microbial organisms, there's a 99% chance that there won't be actual animals or monsters. It would just be impossible for them to develop in such conditions. But it would make a great horror movie. Researchers want to send robots or drones to explore the tunnels first, and then see if they're safe enough for humans. And it's not just the US getting in on the action. China is also investigating the possibility of using these moon caves as a future base, showing that the race to explore and settle the moon is heating up. Back when Apollo missions were launched, astronauts returning from the moon claimed that moon dust, the gray sand-like dust covering much of the satellite surface, smelled and tasted, yes, they actually tasted it, like gunpowder. What the stuff moon dust is made of is nothing like gunpowder. About half of its composition is silicon dioxide glass from impacts with meteorites. They hit the surface of the moon at incredible speeds. Whoa! The high temperature makes the topsoil fuse into glass, and the impact shatters it right afterwards, creating the gray and clingy dust. The rest of moon dust ingredients are minerals such as iron, calcium, and magnesium, while old-fashioned gunpowder consists mainly of saltpeter, charcoal, and sulfur. In other words, moon dust shouldn't smell like gunpowder, but it does. Besides, when astronauts brought samples of it back to Earth, there was no smell left at all. One explanation could be that the moon is similar, in a way, to Earth's sand deserts, like the Sahara. It's extremely dry and arid. When you sniff the air in a desert, you don't smell anything. But if you get caught in the rain there, the moisture will raise all kinds of odors from the ground that were previously trapped in the dry sand. With moon dust, it might be similar. While on the surface of the moon, it doesn't smell at all. Not that the astronauts could sniff at it wearing their spacesuits, though. But when brought back inside the landing module, the dust came into contact with moisture in the air and started emitting its strange odor. Another reason for this could be a reaction of moon dust to the solar wind. Ionized particles from the sun hit the bare surface of the moon and stay there. There's no thick atmosphere to protect it from those ions, so they travel freely right to the ground. They're very lightweight, so they can fly off and sort of evaporate from the slightest of nudges. And when astronauts took the moon dust samples to the landing module, those particles could have started moving around and giving off the specific smell. This might also explain why the samples didn't keep their odor when brought back to Earth. Since the particles are so light, they might have flown off the samples already in the landing module. And when they were placed in airtight containers, there were little or no ions left on them. Another explanation is that those airtight containers weren't so airtight after all. Moon dust is basically very small crystals with extremely sharp edges. They unexpectedly made tiny cuts in the seals, letting in air and moisture, and so the ionized particles leaked out of the containers. Scientists believe they should study moon dust on the surface of the moon itself to find out everything about its properties. Now, there are hundreds of thousands of craters on the surface of the moon made by falling asteroids, but one of them drew a lot of attention. It turned out to not be just an impact crater, but a tube, looking most like an entrance to a cave system. Scientists found a specific echo pattern that suggested there was a hollow area beneath. They discovered more echo patterns at a couple of places near the hole, so there could be more lunar tubes there. But in this big tube, you could place an entire football field. Researchers believe there could be an entire geological wonderland under the surface. It could be a good shelter for astronauts landing on the moon, or even be a harbor for a lunar colony. No one ever managed to stay on the moon for more than 3 days because of the conditions on the satellite. Wide range of temperatures, low atmosphere, no magnetic field would protect life on the surface from things like radiation or solar wind. Astronauts wear spacesuits. They can't protect them over long periods of time, but a lava tube could. When a lava flow cools, it gets a hard crust, which later thickens and creates a roof over that same lava. It continues to flow, but when it stops, the channel can drain, and that's how an empty tube appears. Our planet also has lava tubes, but they're not as big as the one found on the moon. Back in 1178, I wasn't around then, at least 5 people in England claimed they had seen the moon split into 2 from its upper tip. It was in the shape of a crescent at the time of the event. When the crack widened, fire started blazing from it, which the single monk who chronicled it described it as a flaming torch sprang up, spewing out fire, hot coals, and sparks. Then the moon started shifting around and pulsating, but soon stopped and turned a slightly darker shade. The event didn't receive much attention from scientists, though, until the second half of the 20th century. Researchers studied the chronicle and figured out there was a huge 14-mile-wide crater on the surface of the moon at about the spot described in the book. Only a very large asteroid could have left such a scar on the satellite's face. And when they investigated it more closely, they found out it was pretty recent by astronomical standards. In fact, it really could have appeared about 800 years ago. But in that case, millions of fragments from the asteroid and the moon would have hit the Earth as well, and then people would have seen an incredible meteor shower. It would have been very bright, and the memories of it would have definitely been in the archives. But that didn't happen. In addition, many scientists argue that the crater isn't as young as it might seem. The most popular and justified theory is that it's about 1 to 10 million years old. If it had appeared as recently as 800 years ago, parts of the surface of the moon in and around the crater would still have been warm from the impact. The most likely explanation of what really happened back in 1178 is that observers were extremely lucky to see an asteroid falling towards the Earth and burning in our planet's atmosphere. The spectacle would have been incredible, and seen from a proper angle, the burst of the asteroid could have really looked like it was the moon exploding. That would explain why there were so few witnesses of the phenomenon. The right spot to see the show, as they did, was only a couple of miles wide. As for real events on the moon, water and oxygen were unexpectedly discovered on it not long ago. Water might have been brought to the satellite by asteroids hitting its surface, many of them carrying H2O molecules, and those that are left on the moon in tiny amounts after the impact. There's precious little water there, though. By comparison, even the Sahara Desert has more of it than the entire moon. Oxygen is also present as separate molecules floating around, so you still can't breathe on the moon. Solar wind brought them there. Waves of energy from the sun travel at extremely high speeds through space, scrape oxygen from the upper parts of our atmosphere, and carry it further. Eventually, the wind with the oxygen molecules reaches the moon. And that's where something incredible happens. The moon starts rusting. There's plenty of iron in the lunar soil, and when it's exposed to oxygen and water, it naturally rusts. Some parts of the moon have actually already turned slightly reddish. They're regions where there's the highest concentration of molecules. If this process goes on long enough, in the distant future, the moon will look like Mars. It will turn orange-red. Yes, the signature color of Mars came exactly from the corrosion that began there thousands and thousands of years ago, when there were rivers and seas with water and an atmosphere with oxygen. Another unusual phenomenon is the blue and red lights on the moon. They can be seen when it's crescent-shaped. The flashes come and go very quickly, almost like lightning. And in fact, that's what they basically are, electric bursts. Tidal forces are to blame for this. They cause mechanical stress buildup in the rocks. This can produce an electric field, which creates the blue flashes that have surprised many amateur astronomers. But still, there's so far been no green cheese discovered there, or moon pies for that matter. Disappointing, I know. So tonight, go out and look at the moon through a telescope, and you'll see many craters. No one still knows how they appeared there. Some of them have formed recently. Scientists have discovered a double crater on the moon that appeared for a strange reason. In March, a rocket crashed into the moon, and no one knows who owned it and why it left such a trail. If a regular rocket had fallen there, it would have left one hole. A standard space rocket has a heavy engine on one side and a lighter fuel tank on the other. But this time, there had to be two heavy sides on one rocket to leave a double crater. That's strange. No one knows what it is, and no one has claimed to be the owner. It was probably part of a large 3-ton rocket. This piece had been flying in space for several years. At first, astronomers thought it belonged to SpaceX, but the company denied this claim. Also, they thought that China had launched the rocket, but this was also wrong. In the near future, NASA experts hope to find out the truth. The problem with tracking such rockets and space debris is that this is quite expensive. Companies don't want to spend too much money on it. But soon, this will change. People will have to spend billions of dollars to monitor garbage or destroy it, since it's getting too crowded in space. Space companies will have to solve this problem, as it poses a serious danger to satellites and spacecraft. Just take a look. There are millions of pieces of satellites and rockets flying in space. Some of them are the size of a basketball, others are as tiny as a raindrop. The total weight of all this debris is about 9,000 tons. This is almost 2,000 tons heavier than the Eiffel Tower. Okay, all this garbage is floating there, so what? The problem is that it's not just floating, it's moving at a speed of 17,500 miles per hour. A tennis ball will fall apart into several pieces at such a speed on the surface of our planet because of air resistance. But there's no air in space. Nothing prevents a tiny piece of metal from reaching a speed 20 times faster than the speed of sound. A piece of paint at this speed can easily damage the casing of a spaceship. Once, several shuttle portholes were replaced because of the damage caused by flying chunks of paint. Now imagine what a piece of metal the size of a basketball can do to a spaceship. It could bring down the International Space Station. Many satellites were destroyed by space debris that crashed into them, and when those satellites exploded, they burst into thousands of small parts, which also turned into dangerous flying objects. For example, in 1996, a fragment of a rocket damaged 10 years earlier crashed into a French satellite. In 2009, a failed spacecraft destroyed another commercial ship. As a result of the collision, about 2,300 tracked fragments appeared, as well as lots of tiny untracked ones. Today, satellite operators receive warnings about potential collisions with space debris, but these messages are often either inaccurate or reach the operators too late. Imagine that a screw is flying at great speed toward your satellite. You'll hardly have time to dodge it. Perhaps it won't hit your satellite at all. This uncertainty makes these warning sensors useless. The problem becomes much more serious when it concerns the ISS crew members. A durable spacesuit can't guarantee protection from flying debris, and the station itself is too large to save itself from big objects by dodging. To keep astronauts safe, scientists have a catalog of things that are the size of softballs or bigger. They monitor thousands of fragments and analyze their trajectories, material, and dimensions. Next, they use the pizza box method to dodge garbage. This is the unofficial name for an imaginary square that is used to calculate the risks of a collision with space debris. So imagine a giant pizza box. It is 2.5 miles deep, 30 miles wide, and 30 miles long. Now put the entire International Space Station in this box. Yeah, okay, you can have it with pepperoni. Anyway, if some space object is heading toward the edge of the box, the crew will begin to develop a plan of action. The box's radius is quite large compared to the station, since it's difficult to calculate the debris' trajectory. If there's a chance that something might approach the box, then it can also damage the station. When operators receive a signal about approaching debris, they analyze it. Depending on the data received, the crew begins to act in a certain way. If it's something small and heading for some part of the ISS, the astronaut should evacuate from this part, and after that, they'll do repairs there. If something big is approaching, the entire station can perform an evasive maneuver with the help of the engines or a docked spacecraft. One such trick required about 5 hours of hard work. The station is a big, clumsy ship, so it's important to know about the threat in advance. From 1999 to 2020, the ISS made 29 maneuvers to avoid collisions. 3 of them occurred in 2020, and there will be more since the amount of garbage increases. If some object is too big and fast and can damage critical components, and it's impossible to dodge, the entire crew will have to evacuate. In the future, NASA and other space agencies will have to think about how to destroy this debris or remove it from orbit. One option is catching everything with extensive space nets. One agency suggested developing a solar sail that clings to debris and propels it to a low orbit. Another wanted to use an electrodynamic cable to slow down the speed of space debris with the current. This maneuver will cause space garbage to move toward the surface of Earth and burn up in the atmosphere. But what if one of these pieces still reaches the ground? Even now, many satellite parts fall on Earth. Fortunately, this is not so dangerous. The probability of cosmic garbage falling on your house is minimal. In addition, 70% of our planet is covered with water. Of the remaining 30%, only 3 to 10% are occupied by people. Almost all space debris falls into the ocean or unpopulated parts of dry land. But let's say some part of a satellite damages your property. In that case, the company that owns this space object will cover the losses. Such cases are rare and occur because of accidents in orbit. But sometimes, companies intentionally abandon their satellites. If a spacecraft is out of order, they turn it off and use the remaining fuel to slow it out of orbit and drop it in a safe place. Almost all such objects fall in the region of the spacecraft cemetery. It's located at the most remote point on Earth, Point Nemo. It's in the southern Pacific Ocean, east of New Zealand. The nearest island is more than 1,000 miles away. The distance to the International Space Station is much smaller. It's challenging to get to this place since no ships travel there. That's why most satellites end up in that area. It looks like an endless sea. The ocean there absorbs explosive waves of any power without consequences. Even if some fallen ship or rocket causes a giant wave, it dissipates long before it reaches dry land. Fish and other marine creatures are also not at risk. Point Nemo is one of the least inhabited areas on Earth. Underwater currents carry nutrients through the ocean, and tiny living creatures such as phytoplankton and other organisms feed on them. But these currents don't reach Point Nemo. Another way to deliver nutrients in the ocean is wind, but there's almost no wind at Point Nemo. This place doesn't have enough food to let large life forms develop. Just imagine how lonely and silent it is there. Sometimes a broken rocket breaks this silence, crashing into the water at great speed and descending to the seabed, where thousands of other satellites are waiting to welcome it.